Substitution and income effects, as well as the law of demand. This is kind of a foundational concept that will play a role in the rest of this quarter, as substitution and income effects come in and out of a lot of the topics, and so this will kind of lay a foundation for it. We already know the law of demand. We've been doing it since midterm 1, and we already know with the Cobb-Douglas, this is our demand of x1, this is our demand of x2. We were just plugging in values for income and prices when we were finding our optimal bundle. And so when you have demand, you just go ahead and leave the prices and income as variables. When we have perfect subs, we already know that we want one of those corner solutions. So if we are getting the demand of x1, it would just be income over its price. And if we are getting the demand of x2, it would just be income over its price as well. And then for perfect complements, we basically go through the steps that we would take in order to find this optimal bundle. So we know our first step with perfect complements is to set the two goods equal to one another. And then our second step is always to plug that into the budget constraint. So we're going to have P1 x1 plus P2. Since x1 equals x2, I'm just going to go ahead and plug in x1 here for x2 equals our income. And then we can get the demand of x1 by simply isolating it and leaving our prices and income as variables. So I can do one of these and then go ahead and divide by that P1 plus P2. And so by getting that x1 alone, I'm able to find the demand of x1. So this is the demand of x1, and we see that x1 here would have to be a normal good because as income goes up, its demand is going up. It would also have to be an ordinary good because as its price goes up, its demand is going down since that price is in the denominator. So that's kind of just an example of how you derive the demand of a good. You just go through the steps, but you leave the prices and income as variables. Next up, we have substitution and income effects. For the substitution effect, we are capturing how consumers adjust their consumption in response to a price change specifically. The idea here is as a price of one good rises, let's say x1's price is rising, we are always going to go the opposite direction of a price change for our own good. So since x1's price is going up, we're always going to have this demand going down. No matter what, substitution effect is always consistent. So we're going to go the opposite direction of price change. Then x2 is always going to go the opposite direction of x1, no matter what. The idea here is that x1's price is getting higher, we actually want less of it, and we're going to go ahead and substitute x2 in. And so these will always be opposite directions of one another, and this will always be the opposite direction of its own price change. Then for income effects, we're capturing how consumers adjust their consumption due to a change in their real income and their purchasing power. So there's some hints in the question that will help us with income effect, and that includes normal or inferior goods. We already know what normal goods are. As our income rises, our demand for that good is going to rise. That's a normal thing to happen. Inferior is the opposite. As our income goes up, we actually want less of that good. Like fast food or ramen, the more money we have, the less we want these inferior goods. Another way to think of this is we take the derivative of our demand of x1 with respect to m. Whatever is on the bottom of that derivative there means with respect to. So if we took the derivative of our demand for x1 with respect to m, we should get a positive number for a normal good. If it's negative, it's going to be inferior, but positive will be a normal good. Another thing that will tell us what's going on with income effect is if we are a buyer or a seller. So this kind of goes into another topic in 10A. We still have our goods x1 and x2, but now with buying and selling, we introduce endowments. Endowments are initial holdings of goods that we already have. And so the idea here is that our income is actually the value of our endowment, because if we wish, we can go sell our endowments. And so then we can calculate our income by multiplying the endowment by its price. To figure out if we're a buyer or a seller, we're going to calculate the net demand of that good. So for x1, let's say that we have an optimal bundle here of x1, x2 equals 12.5. That's our optimal amount of x1 and x2. Then let's say our endowment point here is going to be 10, 10. So this equals 10 and this equals 10. To figure out our net demand of x1, we simply just do our optimal amount of x1 minus our endowment of 10. So our net demand would be 2. Since we have a positive net demand, we are a buyer because we want more than we have in our endowment, right? So we're demanding 2 of x1, we are a buyer. Then if we calculate the net demand of x2, we would have this 5 minus this 10. So we would have a net demand of negative 5. Since we have a negative net demand, we are a seller. We have more than we want. We only want 5. So we have 5 left over that we can go and sell and get rid of, make money off of. So that's the idea of buyer and seller. As you see here, if we had an indifference curve up on this part here, we would be a seller of x1 because we only want this much x1, but we have this much x1 thanks to our endowment. Same idea over here. If this is where our indifference curve is, we want this much x1, but we only have this much x1 because of our endowment. So we want more than we have. We're going to buy if we're on that side of the budget constraint. Additionally, if we have a change of prices and we redraw our budget constraint, that budget constraint is always going to go through the endowment point no matter what. It's always going to go through this endowment right here because that endowment is always affordable to us. Finally, some hints in the question that tell us the total effect of what goes on overall. To begin with, we have substitutes. We know by definition of substitutes, as the price of one good goes up, the demand of the other good goes up as well. The way we think about this is if we have a price increase of x1, we actually want less of x1. We're going to go ahead and substitute x2 in there, right? Then complements. When the price of one good goes up, the demand of the other good goes down, right? Notice with substitutes and complements, we talk about the price of one good, the demand of the other good. So with complements, we want these goods together, right? And so if the price of x1 is going up, we want less of x1 and we want less of x2 because we only like to consume these goods together. Then ordinary goods, we already know what this is. As the price of one good goes up, the demand for that same good goes down. Giffen goods are the opposite. As the price goes up, your demand for that same good goes up. Here, the substitution effect is stronger, and with Giffen goods, the income effect is stronger, and let me kind of show you what that looks like. So for substitution and income effect, they're going to give you some hints in the question that will be helpful. The price of Y increases. This tells us what's going on with substitution effect. And then they tell us that Y is an ordinary inferior good. Ordinary tells us about the total effect, and inferior good tells us about the income effect. So first we have that price of Y increasing, so P2 is going up. We know for the substitution effect that X2 is just going to go the opposite direction of its price change, and then X1 is going to go the opposite direction of X2. Then they tell us that it is an inferior good. So when we have a price rise, this means for substitution and income effect that our income is ambiguously going down. When prices go up, our income goes down because we're spending more money on those goods. So since our income is going down, but X2 is an inferior good, we know for inferior goods, as income goes down, our demand for that good is actually going to go up. And then ordinary tells us about the overall effect of what's actually happening. So since Y is ordinary, we know as its price goes up, the demand for that good is going to go down. So which of these is consistent with what's going on? The substitution effect. This matches the direction of what really happens overall, that total effect. So the substitution effect is larger than the income effect. And so that's why this is consistent. Then for Giffen goods, is that X2 is a Giffen good and there's a decrease in the price of X2. Also note for Giffen goods, if it's a Giffen good, it must be an inferior good. All Giffen goods are inferior goods. This doesn't mean that all inferior goods are Giffen goods. However, if you are a Giffen good, you are an inferior good. And that's important because it tells us about the income effect. Giffen good tells us about the total effect, and then decrease in price of X2 will be that substitution effect. So since we have P2 going down, we know that our demand for X2 is going to go up, opposite of price change, and X1 is going to be the opposite of X2. Then we have that it's an inferior good. So since our prices are going down, our income is ambiguously going up because things are getting relatively cheaper, income's going up. Since income is going up and x2 is an inferior good, we're actually going to consume less of x2. Then we know for our total effect for a Giffen good, if the price of 2 is going down, our demand for x2 is also going down by definition of Giffen good. So this matches the direction of the income effect, P2 going down, x2 going down, so the income effect must be larger than substitution effect, and that's consistent with this definition. I have some questions about demand. So it says good 2 is a complement for good 1. Since we're talking about the demand of good 2 here, as we can see, these are all the demands of x2. We know by definition of complement, as the other good's price increase, the demand of the other good should decrease, right? If prices are going up, that means that our demand for x1 is going down, and demand for x2 is going down with it. As we want to consume them together, they complement each other. So we're going to see which of these is consistent. As P1 goes up, the overall demand will go down. We see here we're subtracting P1, so the more and more P1 goes up, the smaller and smaller this overall demand gets due to the fact that we're subtracting. So this would be a complement. If they ask which would be a substitute for x1, this means that as the price of x1 is going up, the demand for x2 would actually be going up because we're going to go ahead and sub it in for x1. So that is consistent with this option, because as the price gets higher and higher and higher, our overall demand of x2 would be getting bigger due to the P1 being in the numerator. So that one's a substitute. Okay, for this question, we are told the utility function and that the price of x1 increases. So first off, we know with a price change how substitution effect works. Price of x1 goes up, this demand is going to go down, this is going to go the opposite of x1. Now, to figure out whether these goods are normal, we just have to derive the demand based on our utility function, since they don't give us any more information in the question. So I'm going to do the MRS equals price ratio, which is going to be x2 over x1 for my MRS. And since we don't have a price ratio here, I'm just going to set it equal to P1 over P2. Since I'm looking to solve for biscuits x1, I'm going to go ahead and plug in this to my budget constraint by getting x2 alone. So x2 equals P1 x1 over P2. And then I can plug this in to my budget constraint. So I have P1 x1 plus P2. I'm going to go ahead and plug this in here. P1 x1 over P2 equals my income M. Then I see here that these P2s cancel out, so I'm left with 2P1 x1 equals M. So x1's demand is M over 2P1. I can see by this that x1 is a normal good. That's talking about our income effect. So if it's a normal good, since our prices are increasing, our income is ambiguously decreasing because things are relatively more expensive. And so as income goes down, our demand for this normal good is going to go down as well. That means our answer must be A. The direction of the substitution effect must be the same as the income effect for x1. Now, when we see a question where they're asking about what is the change in quantity, and you see these numerical answers, this is derived using the Hicks substitution effect. So we're going to kind of go through how to calculate that. Okay, our point A is what we've been doing all along. We're just finding our optimal bundle with our prices, income, and utility function. We've done this all through midterm 1. Here are our prices and income given. We see it's a Cobb-Douglas, so we're going to go ahead and set that MRS equal to our price ratio. We know the shortcut for Cobb-Douglas is just going to be C over D. Those are our exponents, times x2 over x1 for our MRS. And so since our exponents are both 1, our MRS is just going to be that x2 over x1. Then I'm going to set that equal to our price ratio. In this case, it was 2 over 2, or 1. So if this is just equal to 1, then x2 equals x1, right? Then we're going to go ahead and plug into our budget constraint. And so if x2 and x1 are equal to one another, I'm just going to go ahead and plug in x1 for both of them. So 2x1 plus 2x1 equals that 32. That's going to mean that my optimal amount of x1 is going to be 8. And since x2 equals x1, my optimal amount of x2 is also 8. So that's my optimal bundle. We've already done that at original prices. Now we're just going to skip really quickly to point C. Super simple, same idea, but we're going to talk about new prices at point C. And so it tells us here in the question that we have a price increase of good 1 to $8. So this is going to be $8 now. So that's going to switch things up a bit. We know our MRS is still going to be that x2 over x1, but now we have a price ratio of 8 over 2. And so that means that we have 8x1 equals 2x2, or 4x1 equals x2. That's going to be our MRS equals price ratio. Let's plug that into the budget constraint. So I have 8x1 plus, we know that 4x1 is our x2, income of 32. So here I see I have 16x1 equals 32. That means my optimal amount of x1 here is going to be 2, and since 4 times x1 equals x2, x2 is going to equal 8. Now, the reason that I go back to point B, so I go ACB, is because we want our original bundle utility at our new prices. So our original bundle utility is going to be whatever utility we got at that point A. So I'm going to find utility at point A. So we know that our optimal bundle at point A was at 8, 8, and we know that our utility function equals x1, x2, and so I'm just going to plug these inputs into my utility function, and out comes a utility level of 64. So my goal is at this point B to get that same utility level of 64, but at my new prices. At my new prices, I know that 4x1 equals x2 after setting MRS equal to the price ratio. So I'm going to go ahead and bring this down here because this is important to me. Step 2 is we're going to use point C's MRS equals price ratio, which is just what we simplified here. And so now I can plug 4x1 in for x2 to my utility function. So I have utility equals x1 times 4x1 equals 64, right? Because I want the utility to be equal to point A's. And then from there, I just have 4x1 squared equals 64. So divide here by 4. x1 squared equals 16. And then I can just take the square root of that. So x1 optimally equals 4. So now we have our point A, our point C, and our point B. I can go ahead and find substitution and income effect for all of these goods individually. So substitution effect is just going to be that point B minus A, and you can do it for each good. So for x1, B minus A is going to be that 4 minus 8. So it's going to be negative 4. And then for x2, we have 16 minus 8, which is going to be 8. And then for income effect, it's going to be C minus B. And so for x1, at point C, we have 2, and at point B, we have 4. So that's going to be a negative 2. And then for x2, we have 8 minus 16, so that's going to be a negative 8. And then total effect is going to be C minus A. So for x1 at C, I have 2, and at A, I have 8, so I'm going to have a total of negative 6. And then for x2, I have 8 minus 8, this is going to be 0. Another key to this is if you did everything correctly, the substitution plus income effect should equate to that total effect, and here we have negative 4 minus 2 is in fact negative 6, so everything went well. And then 8 minus 8 is 0. So everything went well here. So going back to this question, it says, what is the change in quantity of good 1 demanded due to the substitution effect? We saw that that was a -4, as seen here. So this one is exactly the same, but now we just have a perfect subs and our prices and income. So we're going to go ahead and go through each of the points. So we already know optimal bundle original prices. First step for a perfect sub is we want to compare that MRS to our price ratio. So we have 3/2 compared to 1. We know that 3/2 is greater, so we're going to consume X1, and we know that's going to be income over P1, 0, and so that's going to be 10 over 1. 10 is our optimal amount of X1 here. So now we have new prices. It says the price of rice increases our price of X1. So this P1 is going to become $6. So now we have a new MRS compared to price ratio for our point C. And so it's going to be 3/2 compared to 6 over 1. Now we want to consume all of X2. So we're going to have 0. And we're going to have M over P2, our income still being 10, but the price of 2 is still 1. And so then our optimal amount of X2 is going to equal 10 and 0 for X1. Now we have our original bundle utility at our new prices. So we know that our original bundle was 10, 0, and our utility function is 3x1 plus 2x2. So I'm going to go ahead and just plug that 10, 0 in, and so that's going to give me a utility level of 30. Then when I look at the MRS compared to the price ratio, I know at C's prices, I want to consume X2. Since I only want to consume X2, my utility function is only going to have 2x2. I'm just going to completely ignore this X1. I don't want it for this bundle at prices $6 and $1. So I'm going to have 2x2 needs to give me that same utility level of 30, and that would have to mean that X2 equals 15, and X1 would equal 0. Now that I have my 3 points, A, B, and C, I can go ahead and figure out substitution, income, and total effect. Substitution effect is going to be B minus A. I'm just going to solve for X1 here since that's the good that we're deriving the demand for. And so we're going to have B, which is 0, minus A, which has X1 at 10. So 0 minus 10 is -10. And then for my income effect, we know that it's going to be C minus B. So I'm going to have 0 minus 0, and so that's going to give me an income effect of 0. And then just to check my work, I'm going to do total effect, which is C minus A, and so that's going to give me 0 minus 10, -10. Since -10 plus 0 is -10, this checks, my work must be correct. So we have a substitution effect of -10 and an income effect of 0. So the reason that our point B uses the utility at point A using point C's prices is because if we look at what's going on here, we see that A and B lie on the same indifference curve, right? A and B have the same utility level. However, we're starting to adjust our prices. So here's the budget constraint for point A, and then our compensated budget, this blue budget constraint for point B, is parallel to our new budget at point C. So we're beginning to adjust our prices towards point C while still staying on the same indifference curve as point A. So we want point A's utility with point C's prices, and then eventually we move all the way from B to C, so we have our total effect, a new choice on a new indifference curve with new prices. Also for perfect comps, as we were talking about earlier, this A and B is on the same point, and so that's why we have a 0 substitution effect. Since substitution effect is going to be B minus A, they're the same point here, so it's just 0. Substitution effect for perfect comps is always 0, and that's why. Next up here we have Caroline. We see that she is a net buyer of potatoes, so that tells us about that income effect. And we see that they're also an inferior good for her, which also tells us about the income effect. Then they say what happens as the price of potatoes decreases. So it's going to tell us about substitution effect. We have that price of potatoes, which is our P1 going down. So our X1 for substitution effect up and this one down. Now for income effect. Since we are a buyer and prices are going down, this is good for our income. Our income is going up because we're buying them at a lower price. And since income is going up and this is an inferior good for us, we're actually going to consume less of the potatoes due to the income effect. And so the answer must be B. Substitution effect is positive and income effect is negative. We're unsure of the total effect because they're going different directions and there's not enough information in the question to know. Now we move on to endowments. In the question, they tell us what our endowment is. They tell us what our optimal amount would be. They tell us that apples are an inferior good and the price of apples are increasing. So this inferior good tells us about the income effect. This price tells us about the substitution effect. And then this endowment and our optimal bundle tells us whether we are a buyer or a seller. So our net demand is going to be that optimal amount of apples minus our endowment. So our optimal amount of apples would be 8. We want to consume 8, but then we have an endowment of 10. And so since we have a negative net demand, we are a seller. We have a couple left over that we can sell. And so now we have a price increase. Price increase of x1 means that we're going to go the opposite direction for substitution effect. And then as far as income effect, if we have prices going up and we are a seller, that is good for our income. Our income is going up because we're selling things at higher prices. However, it tells us that it is an inferior good. So as income is going up and we have an inferior good, we actually are going to consume less of it. So our income effect for apples is negative. Therefore, our answer is B, the decrease, since the substitution and income effects are both negative. Endowments, when we choose the bundle that leaves us the best off, it's going to be the bundle that brings us the highest amount of income. So what you're going to want to do is just plug these into your budget constraint given the prices that they give you. And then whichever bundle gives you the most income is going to be your favorite optimal bundle. So if we plug in A, we see that we have 50 apples plus 100 plums. And so that's going to give us an income of $200. Whereas at point D, we have 150 apples at $2 each. No plums, but this gives us $300. And so out of all the options, D was our best one. So you just want to have the one with the highest income. Finally, we have a utility maximizing with endowments, and so we see that we have 6 artichokes and 3 heads of broccoli, and here are their prices. How many will we consume to maximize utility? Do is figure out our income, and that's just going to be that endowment times its price, and so in this case we have 6 times $2 plus 3 times $4, so we have an income of 24. And so since we have a Cobb Douglas, I'm going to go ahead and use the shortcut for Cobb Douglas here. And since we're looking for broccoli, I'm going to find my optimal amount of x2 by doing d over c plus d times m over p2. And so our c and d are going to be these exponents, so that 2 is going to be c, d is just going to be 1, and so I'm going to have 1 over 3 times our income we just found of 24, and that price of 2, which was $4, and so then I have 1/3 times 6, which equals 2, and so I'm going to want 2 head of broccoli.